I'm just going to follow through with this presentation. I'm going to sort of try to explain a little bit how PV monitoring is done in Germany at the moment. Hence, the German market has been in the medium-sized range for a couple of years, so I believe this is what's going to be important in Israel, especially in the current year. So I'm going to try to give a little bit of an overview of how we operate at Meteo Control, what we do, and why we do believe professional PV monitoring is important. Okay, this is my agenda for today. So I'm just going to give a very brief profile of the company Meteo Control, and then I'm going to explain why PV monitoring in the first place, and I'm going to talk a little bit about how to maximize your profit and your performance. Meteo Control is the leading provider in technology solutions across the full quality spectrum of photovoltaic installations. I'm going to get to what this means in a second. Basically, to us, our core business is monitoring, but we also got a fairly large independent engineering department providing quality services during the planning and construction phase. The reason for that is that we have this huge source of empirical data, and it would be a shame to waste that knowledge, basically. Just a brief introduction to the company. Meteo Control has pushed its international business in the last year and a half. We got a sister company in the US called Meteo Control North America. We got strategic partners here in Israel, or one strategic partner here in Israel, Lyrico Green, and also in India called Trinity Touch. And we got subsidiaries in Spain, France, and Italy, and various locations in Germany. The company and our directors, they have experience in renewable energies for about 30 years. They have been in the first PV project in Germany called 1,000 Roofs. It was subsidized by the German government in the 90s. We have been involved in PV projects with a total invested capital of 8 billion euros. Okay, I'll just continue. Currently, we monitor over 25,000 photovoltaic systems with a total power of 4.6 gigawatt. We got about 110 employees worldwide. This is basically how our company is constructed. So you got the planning phase, you got the construction phase, and you got the operation phase. Services we offer during the planning phase are manufacturer audits, yield reports, and consulting. During the construction phase, it's construction supervision and technical acceptance. All of this is covered also in a service called technical due diligence. Our core business is the PV monitoring and also the operation management for really large systems. So why PV monitoring? Obviously, there are various causes for loss of yield. You can have a loss of yield during the planning phase, as the system has just been planned very poorly, like as you can see here, shading, for example. Or you can have problems during the construction phase, like bad deliveries of goods, etc. Or you can have problems during the operation phase. Causes for yield loss while the system is built. When the system is built, it's obviously shadowing, reduction output of the modules, dirt on modules. In Israel, it's going to be a lot of problems with sand, and it's going to be very important to have a professional monitoring system to be able to detect when your actual performance is dropping, depending on the amount of dirt on the modules. Degradation, cabling, string failure, inverter failure, and grid failure are also very common sources for yield loss. So this is what's going to look like. I guess you're all pretty familiar with it since Israel has got experience in the photovoltaic sector. So even like just the shading of a little chimney can drop your MPP to 19% underperformance. This is actually one of our managing directors here in the very early days of Meteo Control. He was up on the roof himself. So yeah, obviously like fire due to cabling. So this is where it's getting a bit more interested. So this is empirical data from our independent engineering department. It's basically indicating the severity of yield loss in percentage compared to the number of events of the particular malfunction. So you have full plant shutdown, you have inverter shutdowns and inverter malfunctions. String shutdowns are rather rare. And then communication malfunctions, they happen fairly often, but they obviously have no effect on your yield. So as you can see, like the most important and most crucial source of error is the inverter or full plant shutdown, but this doesn't happen very often, as you can see. So what that basically means is that you really need to have the option to have a good analytical depth on the inverter values. So for example, we believe it's important to have a graph generator in your monitoring software that can actually give you the option that you have all values provided to you by the inverter. You can compare them against each other completely individually, the way you like it and the way the individual problem indicates. So on average, about 5 serious incidents a year per system. This is also data from our independent engineering department. We work very closely with the Fraunhofer Institute, located in Munich. It's a fairly renowned research institute in Germany. A couple of calculations on how defects influence your yield. Obviously, this depends on your feed-in tariff and your currency, etc. So they are just samples. Obviously, everybody has to do the math individually. So for a small system, about 6 kilowatt for a year, it has been with the old feed-in tariff in Germany about 300 euros. If you go to medium-sized plants, 170 kilowatt, you get in the thousands quite quickly. So this is another reason why we believe you need different kind of, or you need a monitoring provider with a fairly wide range of products, going from a more budget solution from smaller systems over a medium solution for medium-sized systems to really full professional operation management for larger plants. Another empirical research study came to this conclusion, that your performance ratio drops up to 5% or increases up to 5% with professional monitoring, because you can just have faster reaction times, as you can see here. Like, there is no system that is really rapidly underperforming for a long period of time. This is where it gets interesting for professional operation management. So this is sort of the next step towards the larger systems, which will be relevant in Israel from next year onwards, probably starting this year as well. So you can see the amount of investment you have to make for your monitoring system and the yield increase you're going to get. So as you can see, for a smaller system, it's a fair bit of an investment, but the bigger the system gets, the smaller the investment is for your monitoring system. So it drops way below 1% of the whole investment for the whole PV system, and it drastically increases your yield. How to maximize your performance and profit. I'm just quickly going through a couple of the independent engineering services. So vendor audits are relevant and necessary. We offer this in cooperation with research institutes. What's very important is yield reports, and our yield reports are bankable. So we work very closely with Deutsche Bank. They send a lot of investors our way if they want an independent quote on the investment, even mainly before the installation has taken place. You have technical due diligence, including yield reports, construction supervision, technical acceptance. Based on the technical acceptance, we offer a plant rating, which is also very interesting for investors. It's a bit like in the financial sector with the AAA. So you basically know, okay, if it has a Meteo Control AAA rating, the system has been planned, constructed, and is operated professionally. We have a very large list of criteria. It's 480 points. This has been developed by our independent engineering department. So for professional monitoring, you need to have an alarm management, and you need to be able to set like tolerances for your alarms, etc. Like, it's also important to set different monitoring profiles, for example. So if you have a time of the year where sandstorms just occur more often, you can adopt the certain alarms according to your weather conditions in a particular time of the year, for example. And what's also very important is like a graph analyzer, for example, a graph creator that I've mentioned before. Very briefly, what I've explained earlier, you'll sort of need a fairly wide product portfolio to cover all the different aspects of costs compared to actual gain of yield. So we believe it's important to have like cheap data loggers or budget data loggers, and then have an industrial line where you actually get more functionality out of it. You can connect more sensors, etc. So we also have like statistics on what we recommend for what system size in terms of monitoring, if you need wind speed, wind direction, etc. Quick overview how monitoring works in general. I think everybody is fairly familiar with it or has dealt with it before. So what we do at Meteo Control, and that's where the Meteo is coming from in the name, is that we work closely with universities to get the meteorological data that we send to our service, and based on that data and the actual components used for the particular system, we calculate a simulation, and this simulation is calculated overnight on our servers, and this gives you a very good indication on how well your system is performing. I'm going to show you the graph later on, and this, for example, is a very handy tool to detect loss of performance or loss of yield, for example, due to dirt on modules. So we are compatible with all leading inverter manufacturers. There's a rough overview of the functionality of a professional monitoring system. So you have your hardware management option, so you have bidirectional communication, meaning that you can actually change the configuration of the data logger on site. Right, for example, adjust offset and tilt of certain sensors, etc. And do that remotely, so before you have to send service staff on site. Alarm management I have mentioned before, and what's also very important is reporting, so you can create reports that are generated automatically. You select which graphics and which raw data you would like to have visualized. You can have sent that to you every day, every week, every fortnight, every year, up to you. So basically you don't have to do anything. After a while you can just check, okay, what's my simulation doing? When do I have to send out cleaning staff? This is the graph I was talking about before. So you can see, for example, that if your actual energy or your performance drops under 70%, it turns yellow, and the yellow triangle up top, or the orange triangle, this is your simulation. If you do not have an irradiance sensor on site, we provide a free satellite data overnight from, like, there's also satellite data available for Israel from next month onwards that calculates the simulation for free, so there's no need to have an irradiance sensor. We obviously recommend it because it's more precise data. Power control, especially when it's getting towards connecting larger systems to the grid, is possible. It's a huge topic in Germany at the moment. I'm probably going to skip that, but obviously we're onto this topic as well. So this is the active power management, which is currently possible, but there are other. This is what it would look like, for example, so you know when your system has been reduced and how much it would have produced, or how much it would have fed into the grid. Obviously, yeah, you can customize the system. So basically, like, the way we approach professional monitoring is that we would like to provide a toolbox to customers that they can then learn to use themselves without, you know, needing us anymore. So you can set the systems up yourself, you can do the alarm management, you can configure the systems, you can have it all in your own layout as well. So it's basically, yeah, it's more like a toolbox. This is the virtual control room. This is what has been in the industrial line. It's like the step-up software for larger system parks, and it's basically, this is for professional operation management staff that really do live monitoring full-time, fully professional. They have a ticketing system, like in a technical support department, for example. You can create maps of your system, so you actually see the individual string that has a problem, so you can direct service staff there, reduce time and costs for service staff. Operation management, I've explained, I think, in sufficient. Our references: international companies like Allianz, Deutsche Bank, for example. And yeah, this is sort of like one of the largest systems we are monitoring. It's 85 megawatt. Yeah, and this is the end of my presentation. I'm going to do a few live demonstrations of a monitoring system in the forum later on if anybody is interested in having more technical questions. So if there are no questions from my side, that would be it. And I would like to thank the organizers for setting this up and also for Lady Green for having me. And I felt very welcome in Israel, and thank you.